Jæja, góðan daginn allir, velkomin á þennan föstudagsfund og nú verður hann hérna Martin með fyrirlestur Azure og svona almennt hvað hann að fara að gera í arkitektur og hann náttúrulega skilur ekkert hvað ég að segja en þetta náttúrulega bara svona almennt generik Azure sem hann að fara að tala og þetta svona höfða til allra, þannig að ég ætla bara að gefa honum orðið. Mike, thank you for this time you're giving us and welcome to this Friday lecture. So I'll give you the torch and yeah, go ahead.
You give me the torch. That's a nice expression. That's cool. All right. Yeah, thanks for inviting me. Actually, it would have been a lot more fun if I was able to do this in person in Iceland. I mean, it's always been a dream to go to Iceland and visit your wonderful country. Seeing that we're not that many in the room, which is okay. Perfectly happy with that. If you have any questions or you have any discussion points or you want to just yell something at me, please don't, but you can. Please unmute yourself if you feel comfortable, or just if you have anything else to say, just do it in the chat. I mean, I can pick it up from there. But typically my sessions are not, how should I put it? I don't like static. I like it dynamic, and I love a good discussion. And everything that I'm telling here is evenly important as the remarks that you're making, so we can have always an open discussion on it. I'm pretty open to those things. So just to give you a heads up, maybe it would be good that I introduce myself first a little bit, because most of you probably won't know me. For those who do know me, I'm sorry already that you have to sit this one through. So my name is Mike Martin. I'm from Belgium. I am working for Microsoft since almost 4 years now. But I've always had a strong feeling with community. I was an Azure MVP for about 6 years. I have still a strong community sense. I'm still running an Azure user group in Belgium. I co-organize conferences like Techorama in Belgium and in the Netherlands. I co-organize Cloud Brew. So there's a couple of things that I'm still doing there. If you want to contact me, you can follow me on Twitter. My handle is over there. It's at TechMike2kx. And if you want to mail me at my Microsoft account in regards to maybe your questions that you have, mimar@microsoft.com. Apparently, that's a pretty cool alias that I have in Turkish, for those who are a little bit interested, because apparently Mimar means architect. And the funny thing is, I'm a cloud solution architect at Microsoft. So that makes my my alias doing worthwhile. And I'm delivering hopefully on the promise of being an architect. And this is a little bit what this session is also about. I want to discuss with you the thing, and you've seen the title, failure is not an option. I want to discuss with you everything in regards to how to build and what you need to build correct cloud solutions on Azure. And I say correct, and a lot of people will already start frowning upon themselves. Why is he saying correct? Well, you will see that there's a lot of things that you can do wrong when you're doing cloud, and that you could do some other things, and that you should think of beforehand, and how you can optimize for real cloud. Okay, so this is a little bit what this talk is about. I call it FINO for short, because failure is not an option, with the subtitle Design for Failure. So let's first have a small introduction to show you a little bit where this is heading. So first of all, I want to go back to the roots. Often we do clouds And a lot of people are addressing cloud typically as a lift and shift. This is where they start. Yeah. And to be honest, they forget about everything else which is in a typical cloud environment. And this is valid for all clouds, whether it's the Microsoft Cloud, whether it's AWS, Alibaba, Google Cloud. Yeah, the others, they're neglectable, but there's still others, right? Like IBM, they're still on the roadmap somewhere. I don't know whether they're still valid, yes or no, because they focus also on the wrong things. They have some cool features that it's really limited. Yeah? But really, this is about going back to the roots. And the roots of cloud computing actually reside back in 4 different pillars. It's about resiliency. It's about elasticity, scalability, and high availability. And to get us started, and the image that I'm showing here is just a reference image that I show a lot. It's pointing back to the Azure Architecture Center. And the Azure Architecture Center is actually your one-stop shop for all your architectural questions, but also when it comes down to writing and creating powerful, correctly funded Azure solutions. Yeah? It's not for the other clouds, but this is really focusing on Azure. Yeah? And you will see some of these references coming back, reference architectures coming back. And this is really your one-stop shop that you need to remember is the Azure Architecture Center. I will go through some examples throughout this entire presentation. Yeah? So taking it back to the roots, let's first set a little bit of a level setting. We started by defining what reliability and resilience is, because a lot of people have a wrong idea on what both are. The reliability is more about the what, where the resilience is the how. Reliability means that you have a system to keep them as high as possible in their SLA without consecrating any downtime. That's the goal of reliability. Where resilience is, if there's a failure, how you want to come back to the original state. Yeah? See this as a resilience you can best compare with a tree. If a tree is in a storm and it's a really big hurricane, Katrina style, you will have trees that will bend down, and after the storm, they will get back up again. That's a little bit the same story that you should have with your cloud solutions. If you're building a cloud solution, you need to make sure that it will be self-healing and resilient enough to get back up after failure. Upon that, you also have, with resilience part, you also have high availability. That doesn't mean if your application is high available that it's also reliable, because the reliability also comes with the resilience part. And it's actually 3 parts when we talk about a reliable application. It's about resiliency, high availability, but also disaster recovery if neither of both precedented features were committed to. So you need to have a backup plan. And I'm not talking about like backup, that's part of it, but you need to also have a what if scenario. If I'm designing for failure and still everything can fail, Murphy is always around the corner. What do I need to do to get back up on my feet? And with that, we also set these things like RTO, RPO, MTTR, and MTTD. Now, these 4 elements, they come together with disaster recovery, and they will define how you will do your disaster recovery. If your main point is to get your data back, you focus more on RPO, where RTO is more focusing on get up your feet as fast as possible. That's a little bit the thing. And that has nothing to do with resilience, because the resilience part is you're trying to be resilient, but you've already let damage. There's already damage done. And that could be anything. That could be business loss, that could be machine loss, that could be data loss. Yeah. The worst part is the business loss, because this is typically unrecoverable. So this is what you need to look at. Now, when we take a look at it from a higher level, they are disaster recovery and backup is not about avoiding failure, it's about recovering failure where high availability and resilience are, right? And you need to make sure that you can have any of those features available in all of your applications. Okay. Now, we as Microsoft, and I'm delivering this as a community guy, but I can say that we as Microsoft, and this is not a sales pitch, right? We as Microsoft, we try to offer that. I mean, we have, as you know, we have 65 regions all over the world, 65 plus regions all over the world. We just announced our own Belgian DC, yeah? And we design our data centers just as evenly important and resilient and reliable as your own. And you may say, yeah, but you're still going down in some cases. Yeah, that's true. We try to avoid going down at all costs. But our infrastructure is built that way, and our solution is built that way that we have a generic entry point, the global service, which is the ARM resource provider, which will talk to all of the data centers wherever you want to deploy pieces of your subscription. And we now have made the promise in the beginning of the year that all of our data centers should be fully availability zone enabled. So all of the services today can be put in availability zones, and these availability zones you can use to be more reliable and more resilient. Yeah, I see. I see what you. Oh no, is it? Yeah, it is. You're absolutely right. It's maybe it is a little bit too small. I think it's over here somewhere. No, the data center. Yeah, I see the button. I see the. Maybe it's an old map. I didn't make that one. This is a movie, so it's not my fault. But I give you. But you need to keep this in mind that we design our data centers to be resilient internally also. If something fails, whether it's storage, whether it's networking, whether it's compute itself, we make sure that we either move in between the data center buildings or between the data center zones itself. And that can also be geographical. As you know, we try to create links between all the different data centers from an availability zone motive. Typically, they are maximum 16 miles apart. And these data center availability zones then can talk to each other, and they are ringed, and you can deploy your applications. And yeah, you get the idea, right? And we manage the movement, the silent movement of these applications for you in case our services would go down. So that's typically one of the services that we offer, but you can use that same element to make your own services a little bit more reliable. And this is the first thing that you should think about when you're doing deployments inside of Azure. And I see a lot of customers and partners that are doing it wrong. They typically just do a single region deployment, which is the worst. And then they set up their service in that single region in a high available mode. Sorry, but if our region goes down, you still have no service available. So you need to take a look at some of these features anyway. But if we can now foresee in every data center, and that promise was made by Mark Risinovich in the beginning of the year to make every single data center zone available, zone capable, sorry, by the end of this year. And actually we met that criteria because now they should all be there. Yeah. So this is a little bit umbrella. There's a good read upon poster that you can print and pin to the wall, or just set it as a background or something, which talks about how the reliability works within Azure and how you can actually use those from your own point of view. As I said, we are trying to do a better job on our own reliability. Risinovich started a blog series where we give you an update so many times on how we improving our reliability. And one of the newer things that we're doing is something called AI Ops. And you've probably seen this during the Ignite of March. Yeah, I always keep forgetting that there's two, but there's it was March. I almost said October, where we actually provide an AI Ops, an intelligent AI Ops that we feed with all the data that is coming from everything inside of ARM and inside of the resources that we have. And we're pushing this forward into something we call Project Nadia. So this is predictive maintenance for manufacturing, but now for keeping machines alive and also keeping sure that we keep the lights running on every service, so that we can up our SLA for your convenience. So that would mean that we can predict if something will go wrong. The only thing that we still need to be able to do here is make sure that we don't do any manual deployments anymore. We had that a couple of years ago. Now we built in a lot of fail safes, and we're using the same kind of things like resource locks and policies, just the way as you people are doing. But we are doing that underneath the hood. So there's a couple of things that are actually being safeguarded in, and we also have some other capabilities that we're using, which I will show at the end of this slideshow. Where we talk about the DevOps way of working with our data. So, but Nadia will actually, what it will do, it can be used for two things. We use this for A/B testing and also chaos testing, and also for multi-arm bandit decisions, meaning that if we pull the plug on something, what will it do, and how will that respond, and more importantly, in production, what will it give as a feedback on alerts to see whether we need to improve our services for some part, and maybe take a deeper look at dependencies. So this will highlight for us the failures in advance, if we have any. That could be anything based upon either telemetry or either service logging or whatever we have. And we can calculate the customer impact from there. If you want to know more about this thing, look at the Inside the Data Center and Azure Update by Marko Sinovic on Ignite March 2021. And it gives a good explanation on how this works.
A question relating to this. Service, does it watch the services itself, or how does it actually? Is there an agent that monitors the?
No, it's on the top node racks. So top rack nodes. I mean, so what this does, it collaborates in our own data centers as a monitoring tool. It is something that you will not use. It's something that we are using to monitor all our services internally and
okay,
keep
so
them
it's
alive.
not. So it's not based on the virtual machines or inside of the virtual machines itself. It's
no.
Okay.
Yeah. So we gathering all the data telemetry from our host services where everything is running, and this is how we work. So this is a little bit on this kind of a environment. So pre-positioning, so it's all the different elements that we have as telemetry that we're getting from our NOCs and our operation centers, and we're pushing this back into Nadia, and we do some model training here, and we optimize that model training. Okay. Now, this brings me to the first part on how to start building your own cloud applications. So keep this data, given in the back of your head. Now, if we take a look at cloud, and people starting with cloud, you typically see this, and this is one of those reference architectures that I was talking about. You see in typical migration where we do a lift and shift of an entire application, any kind of multi-tier that you have, whether it's just a web and a SQL backend or a database backend, or you have a business tier in between, typically you will do that. You will get these kind of solutions. Now, this is okay-ish from a cloud perspective, meaning that everybody's doing VMs, right? Yeah. And I'm saying okay-ish because take a look at the availability that you need to foresee. If you're doing high available VMs in this case, because this is all VM based, right? We have an Active Directory internally on a VNet. We have a jump host. that we provisioned that we can access through the Azure portal, where we can then just get into, and then we go into that network. We have some load balancers there. We also have SQL servers and a lot of VMs where we're running business logic, whether it's Microsoft technology or whatever, doesn't matter. Yeah. Now, if we take a look at the high availability of these machines, so typically you see these subnets being divided. We provide these as DMZs. Okay, you have to look at these as different subnets, DMZs. Not even talking about security here. We're just talking about plain layout on how we should look at those. Now we can build here. In the past, we used to have something called availability sets, and this is good for a single region. Today, we are using availability zones, but still, some of these things will be accurate. If you look at how an availability set got made and how we are looking at VMs today, there's actually a pattern that we can adapt to. And there's two things that we do out of the box if you enable these. It's fault domains and update domains. And you can see fault domains as racks, as physical racks, where the update domains are different blades or nodes where these applications are running, and actually where your VMs are running. So this is really the thing. So, and we typically do a 5-3 setup. So 5 update domains and 3 fault domains, where if we have a fault domain that we're updating, we're not going to touch the other 2. And vice versa. And if this one fails, we still have the other 2, and it will be replicated again on another rack, and so on and so on. This is what Red Dog is doing for us. So Red Dog is actually the fabric controller for Azure, and it plays around with it on multiple services. You can see this thing coming back inside of app services underneath the hood. You can see this coming back in VMs, in scale sets, and so on and so on. So these availability sets have been around for a long time, and that's okay, but you have a lot of plumbing to do. So typically we're going to step away from that, and we're going to take a look at zoning from this case, and we're going to deploy our VMs in different zones, and that way we can have a higher available system. The downside is, and then we can multiply this in multiple regions with some traffic manager in front, and then you have a full high available solution for your current situation. So this is a lift and shift that you've deployed in the end. Now the thing is, what is wrong with this picture? And typically I ask the people here, what can you see what is wrong with this picture? What can possibly go wrong? Well, I'm just going to go immediately in there. The thing is that this doesn't provide us real cloud capabilities. I mean, we are having a failover environment, yeah? But this is typically, if it goes down, we need to monitor it, and we can provide on milliseconds. But what if the virtual network peering was down and we weren't able to connect the databases together? We lost a lot of data. So that means that we need to do a lot of data recovery there, and that means that we also need to do DR. So there's a lot of things wrong with this picture. And the first one that is missing is elasticity. Yeah.
One thing relating to the big picture there. So you talked about lift and shift, which is typical, the solution which everybody goes.
Yeah.
I think that from my perspective is that that this idea of always thinking of moving current service to the data center is mostly wrong. I think the basic idea should be, okay, what services should fit as a SaaS service?
Yes, exactly. That's the next part.
Oh, okay.
That's okay. It's okay. It's good that you think about these things. And indeed, that should be the approach. You should never do a full 100% lift and shift. You should do a kind of a refactored lift and shift, or just a full refactor and a re-architecture. because you will never benefit from anything but the cloud. Then I can even tell you stories where cloud is less beneficiary if you're doing cloud in this kind of a scenario. So this image is it says 1,000 words and they're all screaming. To be honest, in my eyes, I mean, you are using native Azure services in this case, like Traffic Managers is a wonderful service to be high available and giving you a lot of resiliency, because nested profiles, they're awesome. And to be honest, it's one of our most stable services. It's just an underestimated one and an undervalued one sometimes, because now today we have gateways which we are using as a load balancer, and we're using front door. So, but this is still a very valid solution for a lot of things. I'm sorry, coffee. So the things that are missing here is specifically the resilience part and the elasticity part. And you can say, yeah, but you know, VMs, they scale. No, VMs don't scale. I mean, we do have VM scale sets. And scale sets, what they do is you have a definition of a scale set, and you can say, all right, my VM, now I need to scale it out, scale it based upon the metrics, and go. But behind the scenes, you're spinning up a new VM, a clean one. You're adding into the network. It needs to get an IP internally. It needs to have routing. It needs to have all these things. And okay, it's the same VM image, and you have everything predefined on that application. But it's still, first of all, slow. Doesn't scale as fast as you want. And second of all, it's still a VM. And think about consequences of cost, but also of security, for instance. Still impacted by ransomware if you have somebody injecting your VM with some malware because they got access to your image, for instance. Just to give you an idea, software supply chain attacks are nothing new, and we saw that with SolarWinds, for instance. Right? There was code injected in SolarWinds, which gave malicious actors access to all the other pieces. So that's not really a thing. I'm not saying that the VMs are totally evil. Sometimes you cannot go beyond VMs for certain workloads, but please try to avoid this, because the management of scalability and elasticity, because you still need to get those down again too. And I know you can script all this, but this has a lot of more pain coming along with it than it brings you benefit. And also, what if you just need that VM? First of all, it runs a monolith, maybe. Are there sessions in there? Can we route back with those things? Now, typically, you don't want to design your solutions with a session. If you're doing a session and you need to gather state or sessions, push these out of your solution and push these inside of a external cache, for instance, like Redis. Perfectly for that, or Cosmos DB, or even a queue, and take it up from there. That could be storage queues. That could be anything. But we're gonna get there when we go to the greenfield scenario, because it's still about migration. So if we're taking a look at migration, keep these 4 rules in mind. Keep VMs out of scope if possible. Yeah, but then we're not doing a migration anymore. No, not totally true. Because you can easily just pick up any kind of web application. Today, 95% of all web applications that we've written probably can run on either app services or just in a container, and you use that for app services. There you're already there, right? So that's already one thing. And there's some tools that can help you here, like AMP, Azure Migration platform, that can help you identify these gaps and maybe push you into another direction. And also, another rule that you need to keep in mind is if you have a monolith, try already to break it up in layers if you can. Breaking up in layers is the most important thing when you're doing cloud. Why is that? Because every single part of your solution needs to be able to scale and fail independently. This brings you higher resilience and higher availability and reliability of your application. Because if you, for instance, have a front end which is designed to do data gathering, and you have you're pushing that immediately to the database, you will probably throttle your database at a certain point in time, and this will give you a false sentiment of reliability here, because your database at a certain point in time it cannot take the load anymore, and you will start throttling it, and your other users will get timeout. So that's not a really good approach. So, and if you already have layers in there, investigate deeper and see how you can even improve those during the time without giving too much effort to it. So this is the first step that you need to keep in mind. And typically, we're going to start off by doing this approach by looking at the data tier, because that's typically the easiest part to replace. Don't forget that you have if you have a database, it's typically, if it's the same kind of database, it's typically just a connection string that you need to change and done with, right? And in Azure, you can do the same. You can still connect a VNet VM into an Azure SQL database or an Azure SQL database managed instance, for instance, right? And if it's a tier 1 database type, please fix to valid paths. Don't take anything less. And look at maybe some of the serverless capabilities that we have there, or even failover capabilities, because then you already have a fail-safe design for your backend of your data, right? And if not, you need to plan a migration, but a real data migration. Again, VMs are not evil, but if you can take then some additional value out of clouds, typically that's cost. If you can take that VM away with Oracle, your cost will go down probably by, let's say, 70, 80, 90%, because you don't have to pay your Oracle license anymore. You don't have to run that VM, that expensive VM anymore, because typically they need a lot of capabilities on that VM. And maybe you also need to take a look on what you still need of that data. Is it archived data or not, right? So there's some approaches there that you need to take a look at. And we also can do that with AMP if you want to, but that's not a must. We have also database migration assistant. We have AMP. We have Arc that can validate a little bit of that data too. So there's some things that you can work out here. And we talk about data modernization. I mean, you still have a choice, right? It's not like we have no choices whatsoever, but typically don't always look at the same kind of database or same kind of data estate back. Sometimes you need to just switch. You're not going to put blobs inside of a database anymore. You probably want to take them out, because blobs in Azure Storage are way cheaper than if you take a look at it from a SQL Server perspective or a SQL database perspective. I mean, we made the same mistake with SharePoint in the day, right? We used to have SharePoint blobs. They were hosted inside of the SQL database instead of file shares. Today, that's differently, specifically with the cloud, right? So that's a little bit the ways that you should look at it. There's some pathways that can help you there to identify those. And we have data migration services, so most of the databases where you want to go to, and we have native solutions. So we have native solutions for databases if you want them. Yeah, so keep those in mind. There's more to it than just Microsoft technology, and that's the key takeaway here. Also, the next phase of your migration itself would be taking a look at middleware. And this is typically the hardest part, because middleware is we're running WebLogic, we're running all the other stuff. Well, we also have solutions for those. Today we have BIA that we can run inside of app services. We have support for logic apps and event grid, which can also do that kind of an automation, even ADF if you want to, but it's more complex and it isn't that easy. But if you still have integration services running on a SQL server, this can be easily picked up and just pushed inside of ADF on the ADF runtime. So that's also an alternative, right? And that's a lot of things that people don't think about. There's a plethora of choices when we talk about integration platform. There will be more added inside of the greenfield solution, but do know that there's a typical BPM or an orchestration availability with a minimum rewrite impact. So that way you can still you can already shut down, let's say, that old BizTalk environment, for instance, because that can be easily replaced by logic apps. To give you an idea, or to make you think about things. And even sometimes you won't need them anymore, because we can now do those things with Power Apps or with Power Automate, right? So there's a lot of things that you can actually take a look at it from that point of view. The only thing that is an exception here is when you're doing batch computing, but large batching. And I'm not talking about, we're running a nightly script. No, I'm talking about pure batch computing in the sense of HPC. And this is where scale sets do come true, but you define that differently, because batch is actually an engine and a scheduler that can actually optimize for large distributed computing capabilities. And think typically about workloads like rendering of movies, for instance. Disney is doing it. Why can't you? Right? Every Pixar and every latest Star Wars movie and even Marvel movie are now being rendered on Azure Batch and video renders as a service. So there's a combination here, and you don't have to foresee a pool of VMs or a pool or an army of VMs which are already there, dedicated to do that batch rendering. You can call these on demand and make the scaler work for you. Right? And now we talk about front end and back ends, right? And Azure App Service is the first that actually comes to mind, because App Service is a very underrated service in my eyes, because it can do a lot more than just exposing a static website or exposing a .NET website. It can also expose an API. And typically you go with these web interfaces from a migration approach. You can 95% of all cases will just work on App Service. It's just a pickup and redeploy. Now, if you don't have the sources anymore and it's an older thing, you can actually try using the migration wizard. There's a slide here in just a couple of seconds. But what I do urge is that if you're migrating to the cloud anyway, and if you're pushing things away, make sure that you also update all your frameworks, your dependencies, and your languages when needed. And don't keep that old framework alive. We do have a support for certain frameworks up until a certain version, but that will also stop. Migration is also about improvement. You don't want to go and just pick it up because it works. No, you also want to make sure that you're the next gen, and this is where also a lot of cloud solutions are failing, is we're not taking enough time. That will come. That will come anytime soon. By the way, the .NET 6 in preview, because that's it's the full .NET version, latest version, but the service itself is still in preview. We're not giving any support there yet. The stability has been proven of the .NET framework, right? So and it takes time to deploy these things. And you can easily test that. If you still have the sources, just do a right click and just deploy to a web app, and you will see that there's nothing much that change, except for the landing zone where you have it. Because typically a web app is either an Apache or an IIS server. So if you know that, you can just redeploy those. And you can even fiddle with the features of IIS in Apache if you want to. There's some capabilities there. So it doesn't have to limit you, but don't think like inside the data center. Don't think anymore in DMZs. Don't think anymore in all these other services. You need to think also a little bit different, because typically these come from a conservative mindset and not of a growth mindset inside of thinking of moving solutions, because a lot of people don't know what is capable in the cloud, and they only know what they know. a colleague of mine calls them unconscious, incapable. Yeah, so they're not aware that that they're not capable of doing something like that. So this is about that deployment. Custom installers. Yeah, actually, you can try to move those with a migration assistant also. Today we have a migration assistant that can actually move those scenarios into Windows containers, and you can actually install them there. So there's this thing that you can, but if it's a lot with a IIS deployment installer, and typically these are older applications, and if you still need those, maybe you need to take a look also to another kind of scenario there. Yeah. I know that kind of a migration isn't always easy, but maybe look for something which is more applicable to you and which can be bought inside of the cloud, for instance, like a cloud version of, let's say Dynamics, or let's say SAP as a service, or these things, right? Because typically you don't want to use, you don't want to do those in a management anymore. But I get that you want to do those. So if you really want to do those in migration, in Azure Migrations, you can actually use an agent that you can deploy on that IIS, which will pick up your entire environment and push that into a Windows container, and then the Windows container can be then deployed in Kubernetes. And then it's also a migration, which is a little bit more scalable. Yeah. Of course, typically these applications, they don't have like a sessionless and stateless efforts. So you will always have like, we always need to land on the same session, but then you can play along with the containers, the number of containers or the number of pods that you want to use for that, and minimize the number in there. So scale to 0 basically, or scale to 1. Okay. And it's not only that, because also when it comes down to other technologies like non.NET technologies, we always think that Microsoft is only .NET, but what about Java and Java Spring? Well, even there shouldn't be a limit. And we don't only do Java in app services, which can run natively. We don't only do Java in containers, but we also provide you a full Spring Cloud deployment, which we call Azure Spring Cloud. So you can also benefit from those kind of services. So it goes beyond every kind of capability that you need, right? And this is something that you need to look into. Inform yourself before you're starting a migration. Okay, so that brings me to the greenfield scenario. If I'm going too fast, let me know. I still have about 20 minutes and there's still some ground to cover. But feel free to still ask questions, and I hope I answered your questions. I have a hard time. Hi, what? I think it's like that. Give a thumb up or thumb down if I didn't pronounce it correctly. So you're there and you're new inside of Azure, and you say, I don't have any infrastructure today. I don't want to move forward with that old stuff, or I would just want to start with something new. Then there's also greenfield, and greenfield can also go wrong, because you get it. A lot of people are still doing greenfield development on VMs. Why the hell do you want to do that? Typically, if everybody complaining, yeah, we need to patch, we need to manage our VMs, we need to secure them, harden them. I don't have enough rights. This doesn't work. That doesn't work. And also, the item potency is gone. Because your systems are not managed in the same way, typically in between environments. So here, greenfield is more about let's start from scratch and don't do VMs at all, right? But there's a couple of things that I want you to think about. First, if you're starting, don't overcomplexify, but nor underestimate. I see a lot of people still doing designs in this startup by thinking about the things that they know. And typically they start off with, we need to secure area, so we need to start in the network. Why? Why do you still want to do that? Okay, maybe if you have a legal requirement and you want to have a full outside boundary segregating the Azure services from the outside world, then maybe a VNet could be a solution and have everything linked up with private links and service endpoints and all these things. Yeah, but you don't have to, and it will make it also very complex. But it's for some scenarios, it's a very good approach, and it's a better approach than doing it with VMs, right? Some things that you need to keep in mind also is next to the overcomplexify or not doing that, use WAF as a basis. And WAF is what we call in terms well-architected framework. And that's not a term that we own, it's a industry term. The well-architected framework, and every cloud has that one, is a set of practices that goes back inside of, and I'm just immediately going to open up a browser for you, that goes back inside of the architecture center, which discusses all the best practices and principles for designing a correct Azure solution with all the well-architected features calculated in. So if I just do this one, architected framework. Yes, I'm using Bing for those who are doubting. So the Azure well-architected framework is a set of practices and principles. And we have it's a 5-linked stool based upon reliability, security, cost optimization, operational excellence, and performance efficiency. And look, these things are coming back. The things that I was already mentioning are coming back here. And indeed, everything I said before is already hooked upon well-architected framework. And if you want to take a look on how well-architected framework can help you for your today existing environment or your today existing solutions, we can even help you there, because if you take a look at architecture centered, so the landing zone for architecture, you will see here that there's a how-to guide into assess, optimize, and review your workloads. If you open this page, just quickly go back to this one. Nope, that's too far. Come on. Yeah, darn it. Why did it do that? All right, anyway. You will see here that, hey, okay, let's do it like this. That's kind of a feature. Let's go here. So you will see here that the well-architected framework talks about the principles, what kind of design that you need to have, and all the things that come to mind, right? And it's not only about the principles, but also about cloud patterns, bringing in the correct patterns on the correct parts. And a little bit more about that in just a couple of minutes. If you take a look at the, it's not doing anything. Oh yeah, it's really optimizing. Where is it? Where is it? Come on. We also have things that can help you here, like the right technology choices on how to get started in empty clouds. And this is one of the things that we call them decision trees, and you probably guess why. Depending on the kind of the services that you want to implement, there's a decision tree for any kind of workload that we have or any kind of service that you want to use. We have them for compute services, and we even have them sometimes integrated inside the Azure portal, like for networking. We have a wizard that can actually help you guide inside of deciding on what kind of load balancing services that we have. As you can see here, there's a decision tree for that, and there's a lot of choices that you can end up with too. Also in the, here's the review. Also, to help you assimilate your already existing solutions and make sure that you're doing it right, you don't have to start from scratch then. We can help you decide and design or guide you into a better design by doing these things. So what you can do here is we can set a review, and we do a core well-architected review, but you can also do this specifically for Azure Machine Learning or data services. If we go up in there, you can actually select on which pillars you want to evaluate. Let's say, for instance, for security, I want to evaluate on all these things, and you will get a set of questions giving you an insight of what could possibly go wrong with your application. So here, the first question is, have you done a threat analysis of your workload? And then you can start thinking, I did none of the above. And if you then, once you finished and all these boxes are green, and that means that you've filled out the entire list. You can go and view into the guidance, and we will calculate what could possibly go wrong. As you can see here, my system is running critical, and these are all the recommendations that we can give you here. So here we have 7 recommended actions that you can take. And first of all, do threat protection on the workload, adopt threat modeling processing. And that's because I only did answer the first question. If I answer more questions, more of these guidances will come up. So this is the reason why there's only that. So if I were to say, if I go back to my questionnaire and I will say next, and I will say next here, and I will go and do the next question. You will see that if I do next now, and I then view the guidance, you will see that it gives me a little bit more than 7. It gives me 17, and you get the idea, right? And these guidances are typically things that that will guide you from an architectural point of view. And like for here, for instance, there's a checklist which guides us to go away, which will guide us to the it went forward, okay, which will guide us to the governance risk, because we want to implement a best practice for that, and this will give us the opportunity to start looking at landing zones, for instance. So these are the principles that we're gathering here. So, and then also keep in mind the design patterns, technology choices. Try to avoid some stuff, and try to identify where also your weaknesses are, where failure can lie. Is it single region? Is it just a single service that we're using? Have we deployed a single instance of something? Things like that, right? And the other advice that I'm giving is think before acting. Now, the biggest pitfall is that people are thinking, but they are still thinking monolith. I mean, microservices is cool, yeah, but although it is a solution, but thinking in a full monolith is also not the correct way of thinking about building a solution in the correct way. Yeah? So typically you will go upon in layers, and that doesn't mean that you have to think in a full microservices architecture, no, but think about segregation of different parts. And typically you will end up with something like this, where we have a cascading retry and circuit breaker, for instance, where we can say, oh yeah, we push everything inside of an event hub, we pick it up with event sourcing, and my front end will still be happy and alive and is a sync for my backend. So I can still continue working, and I can have that scale because if multiple people are acting upon that front end, they don't have to wait to load and giving them a better experience, but also a better reliability of the service. And service B can just pick up everything in the event source, and if there's too many events in there, it can also scale accordingly. So there's all these little nitty-gritty features that you can use to make it a little bit better. So the layers here are very important. You can also act upon as a circuit breaker. So that way, if your service goes down, your backend goes down, the entire solution doesn't go down, and that's the most important part. If we take some of the challenges that we have in Greenfield is different. Typically distributed components, scale, and cascading. What happens if one service falls down? Will it take the others along with it? So. And if we take a look at it from a cloud solution, perspective, the scaling part is the most important part here, right? And we can have native features in Azure that can help you there. One of the things that you can take a look at is Azure Autoscale, which is an Azure Monitor feature that you can implement on a couple of services. First of all, you can use this with services like app services, but you can also use it with scale sets, as I mentioned earlier. So typically they work with VM underlying infrastructure, but you can also scale your Kubernetes environment. And whether you're doing this in a horizontal way or in a vertical way, whether you're expanding your Kubernetes node pools, or you're expanding your pods, or the number of containers that you're running. Kubernetes can scale in any kind of way. And use extensions to make that scaling work. That scaling can only work if you're doing intermediate layers like event hub or service bus, which scales accordingly, because that's a serverless feature that you have, and you using that server, and we do the scaling for you, right? So you need to. This is something that you need to keep in mind. Again, I'm referring to design principles in this one. You're going to get the slide deck afterwards, so you can click on through. But this is guiding you to design principles specifically for that kind of a scale from a layered solution. If you want to avoid doing these things, typically when you look at solutions in Kubernetes, you typically want to take a look at something what comes as an extension, which in this case is a service mesh. And a service mesh is actually, you can see it as an actor-based framework where you have observability and you have all that metrics that you can also use to make your scaling work, and you have a health care environment underneath that, call it like that. And I know Service Fabric Mesh is still in there, but that was a good approach of a managed service mesh. To have the scalability for you and everything underneath it managed for you, so you didn't have to worry about it. But today you're typically looking at things like Istio, Linkerd, or Open Service Mesh, which is an open source contribution that we did, that you can easily integrate with services like Kubernetes, but also inside of app services and stuff like that. So Service Mesh is there to help you on that part too. After that, do not save data to your microservice. No, never do that. Never do data estate in actually microservices. And never do data estate in a Kubernetes either. At least I suggest not to. There's people that are using microservices and per microservices database. You can do those, but take those outside of your microservice indeed and put them into a more global available environment, right? So service mesh interface. There's frameworks that can help you here, and there's two that I'm just going to briefly mention. C and CF, both started by Microsoft, but now as a fully ambassador in a fully grown-up service, which is Dapper and Open Application Model. These two services, Dapper is a sidecar capability that you can build, and it can use and integrate with Open Service Mesh to have the observability in between all the different services, and it can be deployed anywhere. So this Dapper is just a model that you work around with. An Open Application Model is actually implemented partially into Dapper, and you can actually use Open Application Model to model for any kind of platform where you want to end up on, right? But the more important CNCF service or CNCF project is KIDA. And this will help you scale infinitely. Of course, there's always a hardware requirement and a node requirement, but this will actually help you make it easier. Is scaling based upon events. So event-driven scaling, and typically for Kubernetes, this is one of the more important things that you need to have inside of a cloud solution. So if you have this kind of a solution built up, and you have, let's say, you have a workload with intermediate layers, well, if you do the intermediate layers or everything that is being processed at the front end inside of, let's say, events, you push them inside of Kafka or Service Bus or Event Hub, it doesn't matter, self-hosted or not. KIDA can actually work with that. It's an extra deployable that you have in your Kubernetes environment. And I know Cloud Native is typically pushed next to Kubernetes. It's only a vehicle, right? There's other things that are cloud native too, but typically Kubernetes is given as an example as a cloud native environment. Why? Because it can run anywhere, and it's really a managed solution, but it's still infrastructure, so don't get me wrong. But KIDA can actually help you scale upon based specifically in Azure on the number of nodes that you have, the pods that you have, but also expand with virtual kubelets. So it's actually the engine that you deploy as a Helm chart inside of your Kubernetes environment. And it will monitor all the telemetry based upon Prometheus or Azure Monitor. And it can actually help you scale your environment and also make it a little bit more healthier and a little bit more high available and more reliable and resilient in that matter. And it can be installed anywhere. Now, most of the features that we today are bringing to Azure, we are also using KEDA underneath. And today, if you're deploying, like for instance, Kubernetes on a stack or on HCI and with Arc, we also enabling KEDA out of the box for you, or giving you the opportunity, because it's still a check mark if I'm not mistaken. So you can even use that if you want to, right? This is just some graphical visualization how KEDA works. Another thing that I want you to think about is try to also not only write your own software, but also use a lot of the software. And that can be anything, whether it's a SaaS that you're reusing or just a service that you want to reuse. Best example here is with integrations. This is typically where this comes from. But also, and this is really important, I definitely have to say this to everybody, specifically to ISVs or building their own solution. Don't do any wiring for the below. Don't do any wiring for identity, authentication, and authorization. Just use what is available. You don't want to manage identity yourself, unless it's internally, but that's a different story, because then you need to access other systems too. But if you're writing software solutions that are being exploited by anybody else, you don't want to create your own identity store, and you don't want to create an identity service on top of that. So this is something that you typically want to avoid. And integrations, oh please, never set up any FTP. And if you do want to do that, today we have a new service for that. It's SFTP on Blob service. You can write up for the preview, and you can use that one then to push, right? So you don't have to go and set up a VM, which then again is safe and unsafe. And also FTP is a very unsafe protocol. So it is something that you don't want to go into and step into. So that's one thing that you need to avoid. Better use APIs, messaging, PubSub, or just a blob instead of a full FTP. Yeah? Integrations are more than just having an old school file share on an FTP or a file share for that matter. Since I'm already almost out of time, some of the high-level architectures that you can write with all of these services, never think about going the full 100% mile that you need. I mean, sometimes it's lightweight is more than sufficient enough. I mean, you can set up a web service, and you can set up an Azure App Service inside of with a static API. But you can also do this in blob storage, for instance, or you can also do this as WA in app services. Why is that more important or more interesting? Well, it's because you can use those services. You can use those services in a much cheaper way, in a better scalable way. Yeah? So think about the consequences that it can have. If you have lightweight functionality, then think about things like CDN, for instance. Think about things like Cosmos DB, because there, you have great throughput in a global environment, because Cosmos DB is a global service. It has a global master, and you can leverage those. But also, blob storage accounts, for instance, can be leveraged as a static website host. Combined with Frontdoor and with and there's a great example of a service like that called the URL list, which is actually highly scalable. And that's not the service that I wanted to look for, but this can actually give you better leverage. And this is using things like Frontdoor, and you can run a full scalable service, fully serverless, for the price of a coffee. And I'm talking about an expensive coffee, so Starbucks coffee, for a price of a coffee per month. So that's these are new capabilities that you bring to the cloud that you need to keep in mind, and you're just using a couple of services. Storage is extremely cheap. I mean, you pay like 2 cents per gigabyte. If you're using this with a CDN, maybe that will cost you $1, and then also maybe with front door, which will cost you maybe a couple of dollars per month because of the workload that you have on that. And you can have a service which is fully scalable, add some APIs in between from functions, and you have a service which is almost costing you nothing, and it can be high available. So thinking about these concepts, it's not only about making it more reliable, but also about the cost. Cost CDA is a given when you're doing cloud deployment, and then you can have these beautiful scenarios built up based upon serverless technologies and very cheap technologies that you have. So there's a lot of things to say. I didn't get to the part of rubbing the DevOps on top of that. It's a longer discussion. I'm going to give you the full slide deck, and I'm going to stop off here with a little recap. Take a look at your architecture styles that you have, and look inside of the things that you can improve or go away from, right? Make sure that you take the correct technology choices, what kind of compute that you need, what kind of data storage that you need, but also take a look at messaging and integration. And then push this into a more application architecture and take a look at what kind of references that you can use, what design principles and what patterns that you can improve. And then maybe look at the well-architected framework from a purity point of view. Right? I'm going to give you some other pointers here too, with nice reads and nice pieces of information. We do, there's the link to the Architecture Center. And it's up to you now to build more scalable and more reliable solutions. So, and with that, I just say thank you and keep using the world's computer. Thank you.
Yeah, thank you. This was fantastic. Yeah, I wanted to add to that. You were talking about using software that already existed, specifically open source. That if people are writing their own software, they must think about licensing because it can cause trouble for the company down the line. So, so if you're using open source, the open source says, okay, if you use the open source, the software that you are creating must also be open source. And it has happened that the companies have got into a trouble based on that. So they have to think about this before they use open source. So is there any questions, anything that people want to ask? I think, Arni, you can just unmute if you want to type something or ask something. Typing something
it's
there.
better to ask forgiveness
Sometimes.
than permission.
Yeah, you're right. I mean, I always say that to my boss too when I'm doing my expenses. No, it's a joke. No, you're right. Sometimes it's better to ask for forgiveness than to ask for permission because it will take too long. Thank you, Gunnar. No, you're absolutely right. But typically, if you're using it in an inner source and you're not commercializing it, take indeed a good look at the licensing models behind it. If it's MIT or Apache or whatever you have, you need to make sure that you don't, that you respect the rules of engagement there. Okay. I hope you found it all interesting, by the way.
Yeah, I did. It's very nice. About the licensing stuff, I have a question about it. So let's say you're just doing some in-house project for your company. It's not something that you're going to be selling out or something like that. Do these rules apply to there as well?
Yes.
Yes.
So
how
if
would they find out that I'm using their open source?
It's just samvisku pæling.
Okay, cool. Þannig ég bara góður, sko.
Yeah, well, just have to think of your conscience, basically.
Okay.
Yeah. So they won't find out unless you tell them.
No.
Yeah.
Okay. All right. So you
Okay.
guys keep your mouth shut, and I was never here.
Yeah, unfortunately, it's recorded, man. All right, cool. So I hope you found it useful, this session. I will give you the slides. So I don't know how it will be distributed, but look at your host and he will take it from there. Okay?
Yeah.
Thank you.
All right.
Yeah. Thank you, and giving us your time for this. This was awesome. So,
No problem. And anytime. I mean, if you want to have me come back or something, no problem. Okay.
Yeah. Next time in Iceland then.
Yes, hopefully.
Hopefully. Okay.
All right.
Bye-bye.
Stay safe, everyone. Bye-bye.
Yep. Bye-bye.